Alright everybody, welcome back. We're here for the second video related to the chain rule part 2 lesson. So this is our third total video for section 1 of unit 3 of AP Calculus, the chain rule. And in this video, all we're going to do is work through a couple more examples where we apply the chain rule in context with some of our other derivative rules. So let's get right down to it and look at example 3. We're going to find the derivative of y equals the sine of the quantity x cubed cosine of x. And again, I'm going to use my same mindset that I did in the last video to tell me, what's going on first. If I think about how I would evaluate this function, suppose I substitute 1 in here to find the value of y. I would evaluate what 1 to the third was and what cosine of 1 was, and then I would multiply those together, and then finally I would take the sine of that value. And so when we're taking the derivative, we're starting by taking the derivative of the sine, and so we're going to apply the chain rule first. Inside function is x cubed cosine of x, outside function is sine, and so we're going to take the derivative of the outside. Derivative of sine is cosine, leaving the inside the same. So we leave the x cubed cosine of x in there the same. That's one ugly 3 I just wrote. Times the derivative of the inside. So the derivative, oops, got ahead of myself, I forgot to write the derivative there. Times the derivative of the inside. And so now I'm just going to recopy that first line. And now I'm going to take the derivative of x cubed cosine of x. So in order to do that, this is a product of two things. So I'm going to use the product rule. So I've got x cubed times the derivative of cosine, which is negative sine of x, plus cosine of x times the derivative of x cubed, which is 3x squared. And so let's see, I'm going to go ahead and clean this up. Gives me dy dx equals cosine of the quantity x cubed cosine of x times negative x cubed sine of x plus 3x squared cosine of x. And to simplify this out and make it as easy to understand as possible, I'm going to factor an x squared out of the brackets here and bring that out in front. And then I'm going to put the brackets, and what remains, that's negative x sine of x plus 3 cosine of x, and then finally the cosine of the quantity x cubed cosine of x. I think that's the clearest, most easy to understand way that we can represent our answer there for example 3. And there you go. All right, let's go ahead and we'll move on to example 4. Find the derivative of the following. Y equals the tangent of the quantity 3x squared minus 5 over the secant of the quantity 3x squared plus 7. Again, I think about it from the evaluation standpoint. If I were to evaluate this, I would substitute the value in for x, and I'd figure out what the tangent of that quantity was and what the secant of that quantity was. And the last thing I would do is I would divide those two. That tells me that the division is where I start my derivative here, and therefore I'm going to start with the quotient rule. So I'm going to go ahead here. Dy dx is equal to low times the derivative of high, the derivative of the tangent of 3x squared minus 5. Derivative of tangent is secant squared. So that's the derivative of the outside, leaving the inside the same, times the derivative of the inside, times the derivative of 3x squared minus 5, which is 6x. So there's my low d high minus high d low. Okay, so let's see, I need to take the derivative of low now. The derivative of the secant of the quantity 3x squared plus 7. It's going to be derivative of the outside, leaving the inside the same. The derivative of secant is secant of quantity, tangent of quantity. So it's going to be secant of, leave the inside the same, 3x squared plus 7, tangent of 3x squared plus 7, times the derivative of the inside, which is 6x. I've got all of that over, square the denominator, and away I go. Okay, now let's see. I can factor out a couple of things from these two terms. Notice we've got everything separated by this minus sign right here. So we've got two separate terms, this first term and the second term. And let's see, what can I factor out of those? I can factor a 6x out of both of those. So I can take this 6x out of here and the 6x out of here. What else do I have in common between the two? Looks like I've got a secant of 3x squared plus 7 in common between the two, so I'm going to factor that out as well. And that looks to be it. And what we have left is secant squared of the quantity 3x squared minus 5 minus tangent of the quantity 3x squared minus 5 tangent of the quantity 3x squared plus 7 all over secant squared of 3x squared plus 7. And now I should notice that right here I've got this factor and one of those that I can eliminate from my expression here, and so we end up with dy dx equals 6x times the quantity secant squared of 3x squared minus 5 minus tangent of 3x squared minus 5 tangent of 3x squared plus 7 all over. We got rid of one of those secants, so just secant of 3x squared plus 7. And there's my derivative in example 4. All right, one more. Here we go. Find the derivative of y equals sine squared of x times the tangent of 3x. Again, I go through that evaluation mindset. If I were trying to find the value of this, the last thing that I would do is multiply these two things, which tells me that when I find the derivative, I'm going to start with the product rule. So I've got dy dx is equal to sine squared of x times the derivative of tangent of 3x plus tangent of 3x times the derivative of sine squared of x. And it is very important for us here with this sine squared of x to remember that sine squared of x is equal to the sine of x raised to the second power. That's going to help us in applying the chain rule. So it might actually be better for us, instead of writing this as the derivative of sine squared of x, to rewrite this as the derivative of the quantity sine of x quantity squared. At the very least, we need to think of it that way, even if we don't rewrite it that way. And now I'm going to go ahead and take my derivatives. So I've got sine squared of x times the derivative of the tangent of 3x, and I'm going to use the chain rule on this. The derivative of the tangent is secant squared, leaving the inside the same, times the derivative of the inside. The derivative of 3x is 3, plus tangent of 3x times the derivative of sine of x quantity squared. So now my inside function is sine of x, my outside function is raising it to the second power. So the derivative of this is going to be derivative of the outside, leaving the inside the same, times the derivative of the inside. The derivative of sine of x is cosine of x. And so let's see what we got here. We've got 3 sine squared of x secant squared of 3x plus tangent, sorry, kind of drifted off there for a moment. My brain shut off for just a split second. Plus 2 tangent of 3x sine of x cosine of x. And now I think I'd like to go ahead and factor out what I can, and the only thing that I can factor out of both of these is a sine of x. So I've got sine of x times the quantity 3 sine of x secant squared of 3x plus 2 tangent of 3x cosine of x. And there's my final answer for my derivative. All right, That brings us to the end of the Chain Rule Part 2 lesson. We're going to come back and do a little bit more with the chain rule, multiple applications. We haven't done any problems yet where we've applied the chain rule more than once in a problem, so we're going to do some multiple applications of the chain rule and see how things go from there. So we'll be back next time with the fourth video in Section 3, or Unit 3, Section 1, which will start with the Chain Rule Part 3 lesson. All right, everybody, have a great rest of your day, and I will see you all next time.